Hello and welcome everyone. This is Mohammed Inzamam from SAIMEDHA ECET Coaching Center, Koti, Hyderabad. In this video lecture series of Physics Sadhana, we are discussing about the most expected questions by analyzing ECET PYQs. Okay. Heat and Thermodynamics chapter Physics, we are discussing topic wise ECET PYQs and important questions. My dear students, already the topics thermodynamic processes, ideal gases, laws of thermodynamics, first law of thermodynamics, second law of thermodynamics and entropy concept was updated in the playlist of Physics Sadhana. Today we are going to discuss about a new topic, that is specific heat. Okay. Let's get started. Before getting started, those who have not subscribed the channel, please subscribe the channel and press the bell icon to be notified. Watch till the last of this video, because at the end of the video you will be getting important questions by analyzing all these PYQs. So, all these PYQs are important, and definitely the next expected questions also we are going to see in this very video lecture. Question number 1. For a monoatomic gas, the ratio of specific heats. First of all, let us discuss about this concept of monoatomic, diatomic and polyatomic gas. Okay. So, the first type of gas is monoatomic gas, followed by diatomic gas, and the third one is polyatomic gas. Polyatomic gas. For the monoatomic gas, what is the translational degree of freedom? Okay, translational degree of freedom, rotational degree of freedom, and finally total degree of freedom N. And then we will be having the formula Cp, Cv and gamma, that is Cp by Cv. This tabular form you have to memorize. Monatomic gas, diatomic gas, polyatomic gas, rotational degree of freedom, translational degree of freedom will be 3. Rotational degree of freedom is 0, rotational degree of freedom is 2, rotational degree of freedom is 3. Focus on this one, translational x, y, z. Okay, they are 3 degrees of freedom for irrespective of any type of the gas. Monatomic gas example is argon, helium, whereas diatomic gas example is O2, N2, air. Air is also diatomic gas. Polyatomic gas, we can say oxides of carbon, carbon dioxide, sulfur dioxide, more than 2. Total degree of freedom 3, total degree of freedom 5, total degree of freedom 6. Now, what is the formula for Cp and Cv? Okay. You should know the formula that internal kinetic energy of the molecules is equals to n by 2 times of RT, where du is equals to nr by 2 dt and du by dt is equals to nr by 2, du by dt is called as Cv. So, Cv formula is nr divided by 2. Similarly, what is the formula for enthalpy H? H is equals to U plus PV, H is equals to U plus PV is RT, H is equals to U is N by 2 RT plus RT, dH is equals to, okay, if you can take the RDT common, RDT taken common, N by 2 plus 1, dH by dt is equals to Cp, and this Cp formula is R into 1 plus N divided by 2. So, this is the formula for Cp. Cp, Cv formulas in terms of degree of freedom. First of all, let us write the Cp formula. 1 plus N by 2 into R, 1 plus N by 2, 1 plus 3 by 2, 1 plus 3 divided by 2, 2 plus 3 by 2, this is 5R by 2. 1 plus N by 2, that is 1 plus 5 by 2, that is 2 plus 5 by 2, 2 plus 5 by 2 is 7R by 2. 1 plus N by 2, 1 plus 6 by 2, 6 by 2 is 3, 1 plus 3, 4. So, this is 4R. Similarly, Cv formula nr by 2, Cv is nr by 2, so this is 3R by 2, N is 5, so this is 5R by 2, N is 6, 6R by 2, 6 by 2 is 3, so this is 3R. Finally, Cp by Cv, that is gamma, gamma is adiabatic index. So you need to divide these two now. That is 5r by 2 by 3r by 2. What is the answer? 5 by 3. 7r by 2 by 5r by 2. R by 2 cancel. 7 by 5. 4r by 3r, that is 4 by 3. Numbers also we can say. This is 1.66, this is 1.4 and this one is 1.33. Okay. So this is the entire concept of Cp, Cv, gamma. Okay. Monoatomic, diatomic and polyatomic gases. Now the question asked is for monoatomic. Question asked here is monoatomic gas. What is the ratio of Cp by Cv? What is the ratio of Cp by Cv value here? 1.66. So this is going to become your final answer. ECET 2007. Okay. Repeated asked the question in the 2013 also. Moving on to the next question. The mean translational kinetic energy. I told you that internal energy molecule formula U equal to N by 2 times of RT. Asked question is translational degree of freedom is what? 3. So this formula is going to become what? 3 by 2 RT. Constant, so 3 by 2 KT we can memorize. 3 by 2 KT. Go through it. Usually the formula can be written as like this also. Translational kinetic energy of the molecule. If one molecule is getting asked, usually this is 3 by 2 KT. Number of moles will be taking, molecules will be taking as 1, then the answer would be 3 by 2 KT. But here I will prefer to write in this manner. Next one. The amount of heat given to a body which raises its temperature by 1 degree Celsius. There are 3 definitions that we need to understand. First one is specific heat. Specific heat is heat required to increase temperature by 1 degree Celsius for unit mass. Whereas thermal heat capacity is heat required to decrease temperature, that is change in temperature, by 1 degree Celsius of a body. Of a body means what? Here we are talking about what? Total mass. So in the question is talking about a body, not unit mass. If unit mass is given, then the answer is specific heat. If body is given, then the answer is what? Thermal capacity. So what is the correct answer for this question? Thermal capacity is the correct answer. Similarly, water equivalent is grams of water increase temperature, change in temperature by 1 degree Celsius by using thermal capacity of a body. For example, I will be writing like this. 1 calorie is required to change the temperature 1 degree Celsius of 1 gram. That means this 1 gram is called as water equivalent, and this 1 calorie is called as what? Thermal capacity. You can see thermal capacity and water equivalent magnitude is what? Same. Here is also 1, here is also 1. Okay. So let's move on to the next question now. Next question is unit of water equivalent. Just now I told you grams of water. Water equivalent unit is in grams of water. So what is the unit of water equivalent? Gram. Gram is the unit of water equivalent. Okay. Moving on to the next question. For a monoatomic gas, ratio of specific heat. I told you this is a repeated asked question 2007 and 2013. Monoatomic gas Cp by Cv ratio is 1.66. So what is the correct answer? 1.66. Gamma for monoatomic, gamma for diatomic, gamma for polyatomic. For monoatomic 1.66, for diatomic 1.4, for polyatomic 1.33. So what is the correct answer now? Monoatomic 1.66. Next one. 1 mole of ideal gas is mixed with 1 mole of diatomic gas. The value of gamma mixture is. Now he is talking about mixtures. Okay, gamma mixture. Gamma mixture is equals to Cp mixture divided by Cv mixture. Cp mixture formula N1 Cp1 plus N2 Cp2 divided by N1 plus N2. Similarly, what is the Cv1 form? Cv mixture formula N1 Cv1 N2 Cv2 divided by N1 plus N2. This both gets cancelled. So what is the formula now? N1 Cp1 plus N2 Cp2 divided by N1 Cv1 plus N2 Cv2. In the question is mentioning that number of moles of monoatomic, number of moles of diatomic are 1 mole. So this N is anyhow 1. So the formula is now, formula is what now? Cp1 plus Cp2 divided by Cv1 plus Cv2. We know for monoatomic and diatomic Cp Cv values. What are the Cp values? Cv values. First value was 5r by 2. This is 3r by 2. This one was 7r by 2 and this one was 5r by 2. Okay. So now can you tell me Cp monoatomic is 5r by 2. Okay. Cp diatomic 7r by 2. Cv of monoatomic 3r by 2. Cv of diatomic 5r by 2. 5 plus 7, that is 12r by 2. 3 plus 5, 8r by 2. R by 2, R by 2 cancel. 12 divided by 8. 4 3s are 4 2s are 3 divided by 2. 3 by 2 is how much? 1.5. So what is the final answer for this question going to become? 3 by 2, 1.5 is going to become your correct answer. Go through it. The table you have to memorize. Monoatomic, diatomic, polyatomic. Cp, Cv values also we have remembered. Pause the video, note it down. Let's move on to the next question. Specific heat of a gas at constant volume and specific heat at a gas at a constant pressure are related as Cp, Cv. We know that Cp minus Cv is equals to R. If joule is given per unit joule, R by J. So this is the correct answer. You can say that J is joules equivalent, okay, or we can say J in terms of molecular weight also. Multiply that here, it will become molar specific heat, and R will become what? Universal gas constant. Next one. Specific heat of aluminum is 0.25 calories per gram. That means for 1 gram, for one change in temperature 1 degree Celsius, what is the specific heat value? Specific heat value is 0.25 calories. Okay. The water equivalent of aluminum vessel for 1 kilogram, 1 kilogram, 1 kg, that means 1 into 10 cube gram. 1 into 10 cube gram for change in temperature 1 degree Celsius, you need to multiply here also with 10 cube, na? 10 cube calories. So what is the answer? 250 calories. For 1 gram it is 0.25. For 1000 gram multiply by 1000, 250 calories. This is the correct answer. Go through it, as simple as that. Next question. Monoatomic gamma value is 5 by 3 mixed with diatomic gamma 7 by 5. Then gamma for mixture is equals to. Okay, just now we have seen this question. The answer was 3 by 2, right? Answer was 3 by 2. Repeated asked the question. Yes, this is the question. Gamma is 5 by 3, gamma 7 by 5. What is the gamma mixture is equals to? Okay, answer is what? 3 by 2. Answer is 3 by 2, 1.5. So here directly I can write the answer. And 1 mole of monoatomic, 1 mole of diatomic are mixed with each other, then the answer is going to become 1.5. Nitrogen Cp minus Cv equal to R, assuming that these are molar specific heat and X is equals to universal gas constant. Universal gas constant. Y is equals to universal gas constant. Universal gas constant value never changes. X is equals to Y is equals to 8.314 joule per mole Kelvin. So what is the correct answer going to become? X is equals to Y. On a condition that these are universal gas constant values. If characteristic gas constant values are there, then based on the molecular weight they are going to change. Okay. Next question. Difference between the two specific heats Cp and Cv for gases representing increase in kinetic energy of gas molecule, increase in potential energy, external work done, internal work done. First law of thermodynamics is heat transfer, du equal to d dash q equal to du plus d dash w. But generally we will be taking constant pressure process here to understand better this equation. This formula is what? M into Cp into dt. This formula is M into Cv into dt plus what? dw. If dw is equals to M into dt taken common, this will be going to the left hand side. This is Cp minus Cv. Okay. So this Cp minus Cv is usually indicating what? External work done. Cp minus Cv is going to give you R. Okay, per unit mass, per unit change in temperature, it is giving us what? Work done formula, Cp minus Cv. Next question. Which type of ideal gas will have the largest value for Cp minus Cv? You know Cp minus Cv is equals to R for mono, di, poly, all R will be same, R value only. So the value will be same for what? All mono, di or polyatomic gas. Next question. The distance between the atoms of the diatomic gas remains constant, then its molar specific heat at constant volume. Okay, diatomic gas, mono, poly, Cp values, Cv value. What is the first one? 5R by 2, 3R by 2, 7R by 2, 5R by 2, 4R, 3R. Asked question is diatomic gas. Diatomic gas, and is it asking about constant volume Cv. So what is the correct answer for this question going to become? 5R by 2. You see that table, how many times the question is getting appeared from that very table that we discussed in the question number 1. Make sure you memorize that table now. Moving on to the next question. Heat required to raise 0.5 kg of sand from 30 to 90 degrees Celsius is given by, specific heat is given. We know general formula for heat is what? M into C into change in temperature, delta T. Mass is given as 0.5 kg. Specific heat is given as 830 joule per kg degree Celsius. Kg cancel. Change in temperature is 90 minus 30 degree Celsius. So degree Celsius cancel. So this is 0.5 times of 830. This is 415. 415 into 90 minus 30 is 60. 4 6 are 24. So around your answer would be 24,900 joules. Go through it. Very simple question. Moving on to the next one. AP ECET 2023 shift 1. The ratio of specific heat of monatomic gas is given as. Monatomic gas 1.66. What is that monatomic gas? Cp Cv value. Cp Cv 5R by 2, 3R by 2. Then gamma equal to Cp by Cv. What is that? 5 by 3, 1.66. 1.66 is the asked question. 3 times appeared question, 2007, 2013, 2023. Okay, 3 times. Which of the following gives the relation between Cp and Cv? Already repeated asked question, Cp minus Cv is equals to R. Once asked was per unit joule, now asked question Cp minus Cv, direct answer is R. Molar heat capacity of an ideal gas at constant pressure is greater than constant volume because work has to be done against the external pressure as the gas expands. Work has to be done against the intermolecular forces as the gas expands. Molecule rotate more easily when the gas expands. None of these. Okay, none of these. So if you see Cp value, okay, constant pressure process and constant volume process. In the constant volume, work done is equals to 0. Total amount of heat supplied will be responsible for increasing the temperature. D dash Q equals to du. Temperature increases. Now in the constant pressure process, what happens is D dash Q is equals to du plus D dash W. That means work has to be done against the expansion of water gases, against the external pressure as the gas is going to be expanded. So the first one is going to become your correct answer. Go through it. Only intermolecular forces cannot be the correct answer. Molecule rotate more easily is not going to be the correct answer. Work has to be done against the external pressure as the gas expands. Okay. Work pressure will come into existence. That means more amount of energy you need to be supplied for increasing the temperature. Specific heat is to increase the temperature. Now total amount of heat is utilized for increasing the temperature only. Now the heat is responsible for increasing the temperature and doing the work against the pressure. So more amount of energy you need to supply. That's why Cp value will be greater than what a Cv value. Specific heat is the amount of heat which is required to increase temperature. Okay? Heat required to increase the temperature is called a specific heat. Now here total heat is responsible for increasing the temperature only. Here total heat is responsible for increasing the temperature and doing the external work. That means energy is getting splitting. When energy splits, you need to supply more amount of energy to increase the temperature. That's why Cp will be greater than what a Cv. Go through it once. Chalo, pause the video, note it down. Let's move on to the next question. The next question given over the body, specific heat of a gas has only two values Cp and Cv. Unique value at a given temperature. Can have any values in between 0 and infinity. Depends upon the mass of the gas. No. Solids have one specific heat. Liquids, one specific heat. Gases, two specific heats, Cp and Cv. Only two values will be there, Cp and Cv, two values. The answer is first one. Next question. Supporting the distance between atoms of a diatomic gas to be constant, its specific heat at constant volume is, diatomic is asking now. You know, for the diatomic Cp and Cv values, what are that? 7R by 2 and 5R by 2. At constant volume is asking, constant volume. Constant volume, what is the correct answer? 5R by 2 is the correct answer. Okay. 5R by 2, that R should be in the numerator, it should not be like this. It should be like this, 5R by 2, 3R by 2, R or 1 by 2 R. Okay. So the correct answer is 5R by 2 is the correct answer. Moving on to the next question. Isothermal compressibility of a gas at a pressure P is. First of all, you need to know compressibility and bulk modulus. Okay. Compressibility, let's say compressibility is denoted with symbol what? Let's say it is denoted with what? Beta. Beta is reciprocal of what? Bulk modulus. Bulk modulus. Let's say this bulk modulus is equals to what? K. The formula for bulk modulus is change in pressure divided by change in volume by original volume. This is the formula. Okay. So we know the slope formulas. It is going to become what? dV by V divided by what? dP. This is the formula for what now? Compressibility. We are having slope formulas, one for isothermal, one for adiabatic. Let me write both. Isothermal, adiabatic. What is the formula for dP divided by dV? This is minus P by V. This one is minus gamma P by V. This should be in negative sign. Volume will be getting compressed, so this would be negative sign. Okay. So now we require dV by V whole divided by dP. Okay. First of all, let me talk about isothermal. So what is the isothermal formula for dV by V divided by dP? Or first of all, let's find out the bulk modulus K. K is equals to change in pressure. Change in pressure. Here dV is already there here. So divided by V. dV by V. So left part is only what? Minus P. Left part is only what? Minus P from the slope. Not K. dP is there, dV is there. So this will come here by V. So answer is what? Minus P. Similarly for adiabatic, dP divided by dV by V. Okay, this V is coming here. So this answer is what? Minus gamma P. Minus gamma P. Okay. So now we know the bulk modulus value. That is 1 divided by K. 1 divided by K. What is the K value now? For isothermal, K value is equals to what? Minus P. Okay. Minus of minus P, it's going to become plus P. It's going to become plus P. If I multiply here with minus sign, then what happens? Minus of minus P will become what? Plus P. Here the K is going to become what? Gamma P. This is adiabatic bulk modulus and this one is isothermal bulk modulus. So compressibility is 1 by K. If this is isothermal compressibility, then the answer is going to become what? Answer is going to become what? 1 by P. 1 by P because K equal to P. If it is adiabatic bulk compressibility, then the answer is going to become what? 1 by gamma p. 1 by gamma p. K equal to pressure, bulk modulus is equal to pressure, isothermal. K equal to gamma pressure in adiabatic. Question is isothermal or adiabatic? Isothermal. Isothermal is given, what is the answer? 1 by p. 1 by p. Whereas adiabatic compressibility is given here. So the answer is what? 1 by gamma p. Remember these two questions, very important. So far not yet appeared, but can appear in the examination. Isothermal, bulk modulus, answer is P. Compressibility, 1 by P. Adiabatic bulk modulus, gamma P. Adiabatic compressibility, 1 by gamma P. Because compressibility and bulk modulus are reciprocals to each other. So, pause the video and note it down. Let's move on to the next question. This is the last question, adiabatic compressibility, where the answer is 1 by gamma P. Okay. My dear students, try and understand, these all are very important questions, expected questions in the examination. So far not yet appeared, but can appear in the ECET 2025. So what are you waiting for? If you are started your preparation, download the app SAIMEDHA.in, take the admission as soon as possible, and try to learn as many concepts, okay, because time is the best investment we are having now. If time you are not gonna get for the last 6 months, okay, it's going to be very difficult, because minimum for any competitive examination you want to prepare, you require minimum 6 months. So take the decision as soon as possible and join in the SAIMEDHA Koti, Hyderabad. Press the bell icon to be notified for every update from the SAIMEDHA Hyderabad and subscribe our channel. With such more beautiful content, will be coming back tomorrow. Let's so keep learning with the SAIMEDHA.in.